Hello guys, welcome back to my channel. My name is Vishwa Saitar. I hope you all are doing fine. Let's solve today's problem for Geek for Geek. The problem name is BST Downward Traversal. Okay, so let's solve this problem. The problem is easy, but I feel like it is in medium category, not easy category. So the problem says given an binary search tree, write a unique node value and a target value. You have to find the node whose data is equal to the target and return the sum of all the descent value data which are vertically below the target node. Initially you are at node. If the problem has stopped it here, then we can say it is a very easy problem. But when they go forward here, we have to return the sum of descent node, so it makes a little complicated and it comes under a medium problem. Okay, so now we will break the problem and we will solve it. No need to worry, I'm there. So let's solve it. So what they told, we have, like, let's solve this example. Now what we have to do, we have to find target has 35. So what we will do in binary tree. So what is binary search tree? So binary search tree means its left side is smaller than the root and its right side is larger, or you can say more yeah, more than root. So what I'm telling here, so if we have 25 here, so its left side will be always less and its right side should be always more. As we can see here, in 25 in left side has 20 and 25 in right side we have 35, which is more than a root value, and at left side which is smaller than the root value. Okay, same thing for 20 here. 20's left side is here 15 and here right side is here 22. 22 is more than 20 and 15 is less than 20. Okay, let's check for this guy 35. So 35's left side is how much? 30, which is less than 35. And what is for 45, which is more than 35? So we can say his left side is smaller and right side are bigger. Okay, so we understood what is binary search tree. So now we have to find its what we have to find, we have to find a target value. And here we have given a target has 35. Okay, so now what we'll do, we will see what is a root value. The root value is here 25. So if it is less than 25, the target value is more than 20. Now your target value is more and your root value is less. So now what we have to do, we have to go for right side and see, and we have to see what is this value 35, which is equal to 35, and this is an target value. Okay, so if the problem has stopped here only, this should be a easy problem, but we will go further and we'll solve it. Okay, no need to worry, I'm there. So let's see today. So now what we'll do, first we will code to find a target value. Okay, so we will code here. Before that, we see here root, we should not manipulate root here. So we have to make an temporary or any another node, and like we assign that has to the root. So I will say node, and I will say current will be equal to root. Okay, what I did here, I have reassigned current to the root. So I don't want to modify root, so that's the reason I created a current. Now what I have to do, why the current is not equal to null. So what is this? Why you are asking why should not be equal to null? See, so if we go, if if they told me to find 100 target, if they told me to find 100, okay, so in this case what will happen here? So target here is 100. So what is the root here? Root is 25. So it is obviously 25 is less than 100. So we'll go to the right side. And here 35 is also less than the target value. So it will go to the right side. here 45, here also like more less than like 100, so it will go to the null. So if we find null, so we can say 100 will be not there in the binary tree. I hope you understood why I'm using while loop. So why? Because we have to find the null. So best case scenario for this is while loop, not for loop. Okay, now what I have to do, if I found out the current dot data is equal to the target, then do one thing, break this loop. Do one thing, just break this loop. For that, which function we have to use? We have to use a break function. Okay, I'm clear with here. Now, what we did here? What we did here? Just assume I want to find 15. The target is here 15. Okay, the target is here 15. So obviously the root value is more than 15. So what you do, if the root value is more than the target value, so what do you have to do? You have to go to the left side. Okay, here also the what is the root value here? Root value is 20. So what we want the target value as 15. So what we will do? We have to go to the left side. So what we can say here, if the root dot, not root dot, sorry, we have here send it, current dot data is more than the target, do one thing, just do one thing, change the, go to the left side, go to the left side. Okay, else if in the target is was 15, now the target is, if I assume the target will be 32 or not 32, maybe 45. So what I will do, I will see the root value is here 25 and here 45. So what I will do, I go to the right side, and here again 35 and 45, I will go right side and I will find 45 here. So same thing, if the root value is less than the target, so what you have to do, I have to go to the right side. I hope you understood here. Current dot right, okay, this much we understood till here, till we found out the target. I hope I'm clear till here. So we have done with, we have finished till here. Now what we have to do, we have to return the sum of a decent data where the vertical below the target node initial are root node. Okay, let's understand this problem. So we'll take another example for more clarity. So what I am saying, so I will say this guy is at position 0, and if I go to the left side, I will say it is -1, and if I go to the right side, I will say +1. Okay, now I am going to the right side, it is -1, and here -2, and if I go here, it is +1, it is +2. So you are asking, why are you doing this? Obviously the question will arise like, why I'm doing this? So what I'm doing here, let's say I will create a straight line here, a straight line, very good, a straight line, a straight line, another straight line, and another straight line. Okay, what we did here, we created a straight line in this order. So this is 0, this is -1, -2, 1 and 2. So you will say, how we can say this minus, how we will put the position as a -1? Like you saying, you can say in this diagram, like we can put -1, -2, 1, 2 here easily. But how I can put here, like I have to go here and put -1, -2, like 1 and 2? That's the obvious question. So for that, we will use like this 3 method here. This pre-order, in order, and post order. Okay, so pre-order, what it will do, pre-order first will data, then left, then right, and for in order, left, data, R, and for post order, it should be left, right, and data. So in this scenario, what we will use, we will use this guy. We will do for we will find right, then left, then data. We will manipulate data. Okay, I hope you know this video. If you don't know, please watch that previous video of mine, it will be more clear. So now what we'll do, we will use a formula called, we will use left, right, then data. Okay, now we are here at 25. Okay, we are here at 25. Now what I am saying, if I go to the left side, it should be -1, and if I go to the right side, it should be a +1. Okay, this is a basic assumption I am taking. So here I am at root. So now I have to iterate to the every node here. For that I am using left, right, and then data. Okay, now I will go for the left side. So if I went to the left side, what I am saying, here I will say the position here is 0. Here I will say the position here is 0. So if I go to the left side, what will be the position of 20? The position of 20 will be -1. Okay, now what I have to go? I have to go to the left side. So I will go to the left side again, and here already the position is -1, and if I said here, if I go to the left side, I have to say -1. So here the case will be 15, comma -2. Okay, we have assigned that number to the node, and here also we are saying -2, here is also -1. So now we have to go to the parent cell, and we have to see now what you have to do. We have to assign this guy. So if I go to the right side, what we have to do, here it is -1. So if I go to the right side, I have to add +1. So here the position will be 22, comma -1 +1, because why +1? Right side, so it will be 0. The position will be here 0. So we have filled it is they don't have any child, so we have to go further, and we have to go for this root node. Now what you have to do, we have to go to the right side. I told here, if I go to the right side, I have to add 1. So obviously this will be equal to 35, comma 1. And if I go to the left side, so here it is 1 here, already 1 here. So 1 +1 -1 will be equal to how much? It will be equal to 0. So 30, comma 0. And it doesn't have any left side, so we will go to the right child. And here right child, what we have to do, we have to add the parent value position. Here it was 0, and here to say +1. We are going to the right side, and here we have to go other right side, and it will be 45, comma 2. Now what we did, we assigned the position. Okay, so you are saying why you are assigning the position. Obviously why I'm assigning the position here. So here what they told, I have to add some all the descent node. So what is a descent? Descent is like whatever comes after this guy, 0, 0, and everything. Okay, so I can say whoever has the position 0, see, whoever has a position 0, just add them. Okay, I'm saying what I'm saying again, whoever has position 0, just add them. In this case, this is -2, no, I will change the color to green. Here it is -1, so no. Here it is -1, no. Here it is 0. So in this case, they told, see, I don't have to add his target value, but I have to add the descent value. So what I can say, I will skip the target value, and I will add only descent value. Here, what is it? It is here, target value is 0, and we wanted 0 position. So I will go and add, I will create a sum, and I will add how much? I will add 22. Okay, then I will go further, I will search for here it is 1, so no. Here it is 1 minus, here it is 0. So what I have to do, I have to add 30 here. Now the sum will be equal to 52. I have to add 30. Okay, now I'll go further back. It is here 2, I don't want 2. Here also it's 1, no. I have added all the position who has 0 in it. Okay, the answers for this question will be, answer will be 52. Do we get 52 here? Yeah, we are getting 52. So we can say we fully understood this program. Okay, now we will code it. I can say if the current is not equal to null, if the current is not equal to null. If the current was equal to null, we can say we didn't find any target value. But in some cases, in this case and this case, we have found a target value. So the current will be not equal to null. Okay, I hope you understood. And I will say answer will be equal to 0. And I don't want answer I will create another function. I will create LRD function, and I don't want any variables to any output should be there. So for that, I will do one thing. I will create long answer variable, the global variable. Okay, so no need to do that. Now I have to have a position, and here what was the position here? The position was here 0. So what I will do, I will put 0 here. Okay, after that what I have to do, I have to check here. I have to check it should not be the target value, so I have to have a check value also. Node check will be equal to how much? It will be equal to current. Now I will create a function to find all the element of the descent. I will create a function called, I will find out all the element of the descent. So what should I have? I should have current, then I will have check value, then I will have a position. A position will be equal to 0. Okay, after that, after doing that, we have to return answer. Else, if we didn't find any target here, if the current is equal to null, then what we have to do? If we didn't find any no target node, we have to return -1. What we do? We have to return -1. Okay, now only one task is there to create the pre-order function. So what we'll do, we will say I don't want to give any output, so void find int, not int, sorry, it's a habit, so it should be node root and node check, and another one is the for position, this is int. Okay, I created a function for that. Now if the root is equal to null, then do one thing, just finish the loop. Okay, now what I have to do, what I did here, I went to the left, then right. So what I will do here, first I will do for the left side. So find the left side first. So root should be dot left, and here check will be same, and here what I did here, if I go to the left side, the position is here -1. If I go to the left side, it's -1. So what I will do, position -1. I hope I'm clear here. If now for right side, if root dot right comma check comma, and the position should be +1. Okay, we did it. We created L and R. Now we have to create the data. So what we have to do, we have to check. What we have to check, if position is equal to 0, then only go and add. And another thing we have to check, what you have to check, it should not be equal to the target value. So that's why we had a check value here, and the root should not be equal to the check. Okay, if that is the case, go and add the answer to the node. Okay, go and add to the answer. This is the LRD. We created LRD, simple LRD, and we have got the answer. Let's compile and see if we have any error or not. Yeah, we are not getting any error. Let's submit it. It's getting submitted. Okay, I hope this code was clear. If you still have a doubt, please do comment. I'll surely help you. And if you like this video, please do like, comment and share. It will be great help. And keep coding. Chalo, bye.